Okay, here we go. Today, in this series of videos, we are going to learn how to integrate using a method called partial fractions. It's super useful. It's much easier than some other alternatives, and it has some real applications that we'll talk about after we get good at it. So it'll take a day or so of working on this before we can really jump into some of those practical applications. All right, so as usual, whenever we do a lesson, we do a whole bunch of practice ahead of time. I got a lot of problems that we're going to do that are going to review some things that we've talked about so far and that are going to get us ready to learn partial fractions. It's regular boards go up, please style. What I'm going to do is give you a problem like this and ask you just go ahead and do it, right, as if we were all together. And you can do it. And then, you press pause, you do the problem. And then, once you're ready, you hit play, and then I'll bring my solution up. We can look at the solution. You can see if you're good, if you want to listen to me talk about it, or if you want to go forward in the video a little bit to the next one. And we'll do this for a bunch of little problems. So first one is this one. This is some integration by parts. Now, this 16 right here, you could put it on either the dir side or the int side. My advice, my little push here, put it on the int side. It'll make your fractions and your multiplication and your division a lot easier because the 16 is going to work well with the 2x. So you go ahead, hit pause, use some integration by parts, dir and int, to find the integral of this thing, and my answer will pop up in a moment. Pause, pause, pause. Here it comes. All right, so here is the answer right here. I'm not going to read it out loud. It's 8, 12, 12, 6, plus, plus, minus, minus, sine, cosine, sine, cosine. All right, how do we get there? Well, notice if I put the 16 on the right. Oh, if you want to skip forward and not listen to me explain this because you got this and you feel good with it, go right ahead right now, okay? If you want to hear an explanation of it, then hang around. All right, so 16, if it's over here, then notice when I do my my little reverse chain rule on all these little integration pieces, it works out nicely and doesn't give me messy fractions. It also leaves me with smaller numbers over on this left side. So dir side this, int side this, dir down to 0. I do my arrows diagonally. I do my red plus minus plus minus. And then when I multiply all these things out, I wind up getting this. So integration by parts. Let's practice another one. Let's do the integral of x to the... All right, next one, let's do integral of x to the 5th times ln of x dx. This is one that you should use the escape method to get out of it. So hit pause, try it, see if you can do it. Here comes your solution. All right, so in this box right here, 1/6 x to the 6 ln of x minus 1 over 36 x to the 6 plus c. So how do we go about doing this? Remember, usually when I have this ln and I can't find a u sub for it, if you got this and you're good, go ahead. Go ahead to the next timestamp. If you have an ln and you can't find the u sub for it, typically you put the ln on the dir side because that derives to 1 over x. The x to the 5th lands on the int side, so I get x to the 5th here. Integrate that, power rule. And then I go this direction, and then I go back and do my integral. Remember, they always alternate signs, so the blue one is positive. This product here gives me these. And then my back integral gives me, I get 1/6 x to the 6 times 1 over x, and I integrate it. So integrate with the minus. And then how did this become an x to the 5th? Well, this one divided in to that one to reduce it down to x to the 5th. Then this one stays the same, bam. And then we do some reverse power with this, and I wind up getting 1 over 36 x to the 6 plus a constant. All right, let's do the next problem. All All right, so those two problems were there to help us just remember some of the things that we've been working on. Now we're going to move on to some different type of problems that are going to bounce us into partial fractions. So next one, what I'd like you to do is think back to, elementary math. I want you to add 1/5 plus 2/3. 1/5, so like that. Find a common denominator. You know how to do this. Just going to let you do it. All right, here comes the solution. What we're going to do is multiply this one by 3/3 and multiply this one by 5/5. That's going to make it so they have the same common denominator. This is going to simplify to, all right, 3 times 1 is 3 over 3 times 5 is 15. And then 2 times 5 is 10. So that gives us plus 10 over 15. And then now that they both have that 15 in the denominator, we can add the tops, and I get 13. That's 10 plus 3 over 15. Hopefully you remember how to do that. Let's do another one like that. Let's do 2/5 plus 3/7. Go ahead. Do that one. I'm going to hit pause. You do it. Or you hit pause. All right. Here comes your solution. All right. So what do we get? We get 29 over 35. Hopefully you got that too. All right. So I'm going to give you one more. But before we go any further, I want to show you the goal of partial fractions. So we have this integral right here. If I wanted to try to do this integral with the tools that we have thus far, we would try to do an ln. Why is that? Because I got like a x squared thing in the bottom and an x thing in the top. And if I try to do an ln, I'm going to let the u equal to the bottom. The du gives me 2x plus 4. And now see how I got an x right here? That tells me, all right, so I'm going to divide this by 2. So if I divide everything by 2, I get 1/2 du equals x plus 2. And the x plus 2, the 2 does not match this 3 right here. I can't do anything to the du because it's like kind of already being multiplied here. I can't just like add 1 to it because that would give me du plus 1, and we'll talk more about the issues. But the problem is the du doesn't line up. We've talked about that a lot. So because I got an x plus 3 and an x plus 2. So partial fractions is a way to solve that issue. So don't worry about how we solve it because we're going to do a whole bunch more board work type problems getting ready to do that. But I just want you to know at this point in this lesson that that's my goal, to be able to solve integrals like that. And that's why we're working with these fractions to start here. So keeping that in mind, the next problem that I want you to do is, all right, you were able to combine those types of fractions. So the next one that I'd like you to do is going to be to combine the two fractions, 1 over x minus 2 plus 3 over x plus 4. I want you to combine those into the same fraction, kind of smash them into the same fraction. Use a common denominator. It's going to be the same process you did with these, except there are x's. So go ahead, hit pause, try it. Here comes your answer. So just like with the previous ones, I got to look at the piece that kind of is the combination of the bottom, so the common denominator. So I got an x minus 2 here and an x plus 4 here. So this thing is missing the x plus 4. This is missing the x minus 2. So I multiply it by this because this is a form of 1. And we get 1 times this plus 3 times that. So I'll write that out. So I get this plus this. Now they have the same fraction in the bottom, right? So I'm actually going to write that FOILed out. That gives me, I don't need parentheses, x squared plus 2x minus 8 when we FOIL that. And then the top, look, I got an x plus 4. I got an x here and a 3x here. That's 4x. And then I've got a 4 minus 6, so that gives me a minus 2. So these right here, this original purple, is the equivalent to that. So what is partial fractions? What method am I going to use to do this integral? How do I say this? Imagine I just started with this purple and asked you to do the integral, and we're going to do some of this, of 1 over x minus 2 plus 3. So imagine I asked you to do this integral right here. Integral 1 over x minus 2 plus integral, or plus 3 over x minus 4. This is something that you can do. You might see that it's quick, simple ln's. Okay? This one, its integral is not as easy. If you were to try to do it, you would get stuck for the same reason that we would get stuck up here. So what is the general strategy for partial fractions? And we're going to keep working our way towards this. It's to take one of these and do the opposite of the work that I did here, or that you did, to go from the purple here to the red. We're instead going to go from the red back to the purple. You're going to learn how to do that. And then we're going to wind up with something like this that is easily integratable, as opposed to this, which is not. So I'm going to stop this video here, and I want you to keep that big picture idea stuff in mind, and we will hit the next video and do some more practice, and then eventually I'll show you how to do partial fractions. So, see you soon.